Now we are talking about the foci, okay, or foci, or focal radius for your hyperbola. It's almost the same with ellipse, but let's discuss the applications on your graph. Now, this is one of the types of your hyperbola. The transfer axis is the horizontal one, and the conjugate axis will be the vertical one. The center is h, k. So the vertex will be h minus a, which is a is the x radius for this one. A will be the x radius. So this is the vertex, the other vertexes. And now let's go to the foci, the second image here. Okay, so this kind of graph, since this is the transfer axis, this is the conjugate axis, the focal radius will be here and here. So the distance of your focal radius will be higher or longer than the vertex or the x radius. So if this is your x radius, the focal radius must be longer since they have to be outside the hyperbola. You get the picture, right? So for now, let's see that if the center is 0, 0 and the focal radius is c, then the one of the coordinate of the focus will be negative c, 0, and next one is c, 0 if your hyperbola center is 0, 0. Now, the thing about focus points or foci or foci is when you project a line from a focus to one of the point on your hyperbola like this, and then you project another line from the other focus to the same one. So we have two lines. The first line is D2 and the second line is D1. The difference between D2 and D1 will be consistent when you project to the other points on your hyperbola. So it's different with the ellipse, since in the ellipse, when you sum D2 by D1, it will be consistent to any other points on the hyperbola. But for hyperbola, any other point for on your ellipse, sorry. But for this one, hyperbola, whenever you project a line, two lines from your two focus to a point on your hyperbola, the D2 minus D1 will be consistent in absolute. So the difference, we are talking about the difference. So this is this is one of the displayed, the image that we can discuss. So whenever I project, for example, P1, whenever I project focus 1 to this and focus 2 to this, the difference between D2 and D1 will be the same with if I project focus 1 to point 2 and focus 2 to point 2, the difference between D2 and D1 will be the same with D2 and D1 from this point 1. The same with point 3, if I project to this point from focus 1 and I project another line from focus 2 to the same point, the difference between D2 and D1 will be the same also with the previous. Okay, so the conclusion is, first, the difference in absolute, of course, because we are not talking about the negative value, will always be consistent. And since we use the focal radius, we used c as your focal radius, the distance will be, this is the formula. Where you get it, I hope that you can read it from the textbook because it's already been clear and very easy to understand. So I want you to remember this formula, how to find the focal radius. It's different with the ellipse since this will be the sum of the square of your Rx and Ry. Before an ellipse, the focal radius is the difference. Okay, be careful, we have different formula. The foci coordinates, how to find the foci coordinates. If the transverse axis is horizontal, okay, for example like this, and we know that the focal radius is c, it means the coordinate of your foci will be h minus c, comma k. The k is still the same with the center because the elevation is consistent. And the other point, the other coordinates will be this. If the transfer axis is vertical, then the foci will be on your transfer axis, which is on the vertical axis. It means C points from your K to up and C points from your K to down. I hope. Okay, let me just show the application to the previous examples that we have already graphed. So this is the first equation and the first graph that we want to discuss. So we have known that the x radius is 4, the y radius is 5. Okay, so since the transfer axis is the horizontal one, it means the foci will be around here and here. So the focal radius will be the distance from the center to the focus point. So let's find what is the focal radius. Since the C or focal radius equals square root of rx squared plus ry squared, so it is square root of 4 squared plus 5 squared. So it is equals square root of 16 plus 25 equals square root of 41. Since we cannot simplify square root of 41, and we know that the center of this hyperbola is 2, negative 3, it means the focal points, or the first focal points, will be from 2, negative 3, so it is 2 plus square root of 41, negative 3, and focus 2 will be 2 minus square root of 41, negative 3. Since you need to move square root 41 units to right and to left. Or if we want to plot it on the graph, it means let's find the approximations of your value of square root 41. It is about 6.4. So your foci will be 6.4 units to the right from the center and 6.4 to the left from the center. 1, 2, so it's 1, 2, 3, 4, 5, 6.4. So around here. Okay, this is focal point 2. Let's just make it 2 on the right, and 6.1, 2, 3, 4, 5, 6.4 around here. So this is your focal 1. And this is the coordinates in radicals. And if we go to the second one, since I know that the Rx is 3 and the Ry is 9, and this is your graph, okay, so let's find the focal radius will be goes up and down from the center. The foci will be around here and around here. So the center itself is 5,2. It means let's find the focal radius, which is square root of 3 square plus 9 square, right? So it is equals 9 plus 20, 81. So it is equals square root of 90. So since we can simplify square root of 90, it becomes 3 square root of 10 units. It means the focus coordinates, the foci coordinates, since the center is 5,2, the 5 is always the same. So this will be 5, something, and this will be 5, something. So the coordinates of your focus will be 5, 2. First you add by the focal radius, since we just leave it in radicals, so I can accept these coordinates. The second focus will be 5, 2 minus 3 square root of 10. And since we need to plot it, it means we need to find the approximation value of 3 times square root of 10. If you use your calculator, it will approximate close to 9.5 units. So to plot the Foci, first you goes up from the center 9.5 units. For this one, it's about 11.5. So here, this is your first focus. Why it's 11? So I just add because this is 5,2. So the y is 2. If you goes up, so it's 2 plus 9.5, which is 11.5. It is around here. How about the second focus? So it's the same. Let's go down from 5,2 for 9.5 units. So it is negative 7.5 around here. Okay, this is 5F2. So yeah, this is how you plot. Thank you for listening. So it's all about hyperbola. Next, we're going to meet to a special parabola. It's different with the parabola we have discussed before, since this is not a quadratic function. This is a quadratic relation. So the parabola will speak about a quadratic relation. See you then.